So you start out with cosine 2x minus cosine x equals 0. And I looked at this for a while, but I eventually decided to use one of the alternate cosine functions, which was cosine 2x is equal to 2 cosine squared x minus 1. So that becomes 2 cosine squared x minus 1 minus cosine x equals 0. Then I just reordered it to make it look more like an x squared minus x minus v problem. And I split it up to make it 2 cosine squared x minus 2 cosine x plus cosine x minus 1. And then that becomes 2 cosine x plus 1 and cosine x minus 1. And your two solutions are negative 1/2 and 1. And then the angles you get are 0, pi over 3, and 5 pi over 3.
So that one was an equation, solving the equation. And I liked what she kind of said. She used one of the alternate forms for the cosine of the double angle. There were 3 options. The cosine squared minus sine squared was option number 1. But use the one that works for you in the problem. If there's a cosine in the problem, you don't want to put a sine squared in the problem as well. So pick the one that also has the cosine with it. So that's why she has that 2 cosine squared minus 1. That would be like that other option to use for the cosine of a double angle. Nice job. Any questions on 15? Very nice. So the other one is 23. On Tuesday, seems like it was a long time ago, Tuesday, we did 2 examples. The one example was the equation, like Sabrina did. The other example was drawing a triangle, and I think Virginia has that one. Do you want me to bump off the Apple TV? Although then it's going to turn off. Can we just put your iPad underneath? I think it should work, right? Yeah. There we go.
So you start off with 23 is tangent u equals 1/2, and u is between pi and 3 pi over 2. So I started off by making the triangle, and since tangent is opposite over adjacent, one side is 1 and one side is 2. And then you have to, I used a squared plus b squared equals c squared. And you get 1 squared plus 2 squared equals c squared. So 1 plus 4 is 5, and the square root of that is just square root of 5. So the hypotenuse is the square root of 5. And then you're finding sine 2u of, so you're finding sine 2u, and sine 2u is equal to 2 sine u cosine u. So if you want to find the sine, sine is opposite over hypotenuse. So you would start with 1 over the square root of 5, but then you'd have to move the square root of 5 to the top, so the square root of 5 over 5. And then you would do the same thing with cosine, but you'd have 2 square root of 5 over 5. And then you would combine that. You would multiply square root of 5 times square root of 5 is just 5. And 2 times 2 is 4. And then 5 times 5 is 5. And then the 5's cancel out to get 4 or 5. And then when you do the cosine 2u, it would be the cosine squared u minus sine squared u. So I used the same cosine and sine values, and I squared them. And squared, they would be 4 times 5 over 25, and 5 over 25, because square, you cancel out the square root. So it would be 20 minus 5 over 25, and that reduces to 3 over 5. And then when you're doing tangent to u, you start off with the equation of 2 tangent u, 1 minus tangent squared u. And so the tangent is 1/2, like said in the problem. So it's 2 times 1/2, and then 1 minus 1/2 squared. So 2 times 1/2 is just 2 over 2, so 1. And then 1 minus 1/4. And so it'd be 1 over 3/4. And 1 over anything is just the reciprocal, so you switch it, and so it's 4/3.
Any questions on 23? 21 was similar. So those are the problems where you're given a ratio. A trig ratio is when you have a sine equal to something, tangent equal to something, like the tangent's equal to 1/2. Label the sides of your triangle with that ratio. And then you're expanding with the formulas and plugging the pieces into the formula. Next one. So the other type of problem that you had from yesterday's homework, the last group of problems asked you to verify the identity algebraically, and I wanted to look at number 99. So if you take a peek at your number 99, 99 said the cosine squared, and then it had 2 alpha with the little fishy. I'm just going to make it 2x. Anytime you want to change the variable because you don't like the angle variable that they're using, feel free to change it. And then minus the sine squared of 2 times fishy, or 2x. Supposedly, that's supposed to equal the cosine of 4x. So you're asked to verify, which means prove one side can become the other. So if you look at the left side, that's called the expanded form for the formula. What does that look really close to? Like very similar to what, Brandon?
Cosine squared plus sine squared equals 1.
Yeah, it looks really similar to cosine squared
Plus sine squared.
or minus sine squared.
That too.
Yeah, that too. So it looks similar to, because I'm keeping the minus sign in there, cosine squared minus sine squared. But what is cosine squared minus sine squared equal?
Isn't it cosine 2?
Yeah, that's equal to cosine of 2 times whatever your angle is. A, B, C, D, U, V. Pick a letter, doesn't matter which one. So when you have cosine squared minus sine squared, that's the same thing as having the cosine of your double angle. So that's the double angle formula for cosine. Well, this that they give us pretty much is that double angle formula, except that the angle, this piece here, that represents our angle. Well, an angle doesn't have to be x. An angle could be 90 degrees, it could be 45 degrees, it could be 27 degrees, or it could be 2 times x. That represents the x right here in this formula. So instead of having x, we have something replacing it. So in order to verify this identity, if I take that x, whatever it happens to be, and plug it in for x in the formula, we would have cosine of 2, that's not squared, it's supposed to be 2, times the x. Well, x is 2x. So you're taking your angle and you're still doubling it, but that angle we're doubling is a 2x. So that's how we get the cosine of 4x. By taking whatever's after the function, that becomes our angle, and plugging that in for the angle in the formula. So the cosine squared of 2x minus the sine squared of 2x is equal to the cosine of 4x because the angle is being doubled. That's how you get the 4x. You're doubling the angle. Questions on that? Are there any other questions from the homework that you wanted to look at besides 3 now that you've seen? Any others? So as I said, we'll go over like 2 or more of these just so you can kind of see how they work. But there's I think 5, 6, 7, 6 or 8 on their one review worksheet that just has you kind of break down the identity, verify the identity. It says to write it as a single angle. The goal is to kind of match the expanded form into the broken down short form. So we're going to do 2 examples today with the final set of formulas. So there are 3 different sets that we're learning. There's actually 5 in the book. So we're not doing 2 of the 5. Each set has a formula for sine, cosine, and tangent. So there's an extra 9 on top of the identities. Yes, trig involves a ton of memorization, and there's really, unfortunately, a lot to memorize. So once we're done with all of this, like chapter 5, we'll get into chapter 6, which is a couple of extra formulas, but it doesn't use the identities and the formulas from the chapter 5 stuff. But a lot of these formulas you'll come back, like once you're doing the calc, AP Calc will start pulling in these formulas with the trig that you work on. So the last set of formulas that we're covering are called the half angle formulas. So we looked at angles that we doubled, and now we're going to look at angles that we're going to cut in half. Again, the end goal is for us to be able to find any angle on the unit circle. So we still can't find them all, but we can now get some more angles by using the half angle formula. This is page 31 in your notes. So there are the 3 formulas in the box. So we have the sine and cosine ones, which are pretty similar to each other. The sine is 1 minus cosine over 2 underneath the radical. The cosine of a half angle is 1 plus cosine over 2, and that's underneath the radical. But if you look at the tangent, tangent's the one that gets 3 options, because we can do a little bit with 1 minus the cosine divided by 1 plus cosine. These 2, I would memorize one of them. I wouldn't memorize the one with the radical. We verified this identity in section 5.2. This exact identity was in one of the pages of the notes, or it was a homework problem, or it was even on the test. But 1 minus cosine over sine is equal to sine divided by 1 plus cosine. We can use the conjugate to go back and forth between the 2. So you could pick the left side and work with the left side. You could pick the right side and get the right side equal to the left side. But that is one of the identities that we did, we verified, we confirmed, we proved, whichever word you want to use. So I already memorized one of those 2, not the one with the plus or minus. So in the first example, it wants us to find the exact value of the sine of 105 degrees. Brandon, do you know what 105 degrees, like the sine of 105 degrees is on the unit circle? Not off the top of your head. Is it an angle that we have memorized in the unit circle? Probably not. So it is not one of the angles we have memorized on the unit circle. So instead, we're going to try and use an angle that we have memorized on the unit circle so that we can find the exact value of this without going to that evil calculator. That's the whole goal. Because they didn't have
said if I just said it.
Well, that would have been amazing. But then I would have said, who told you in the last class? So we're going to try and evaluate the sine of 105 degrees using the half angle formula. So the half angle formula says we're going to take the sine of some angle cut in half. So we're going to take an angle, cut it in half, so that when I take that angle and cut it in half, we get 105 degrees. So what angle cut in half would be 105 degrees, Virginia? 210. So that's how the half angle formula works. Like, our goal is to pick an angle that when you divide it by 2, it equals 105. So 210 degrees divided by 2 is 105 degrees. So I'm using the angle, 210. When I cut it in half, I get 105. Questions on how to get that 210? So you want some angle that when you divide it by 2, using the half angle formula, it equals whatever angle we're trying to find. And that's 105 degrees. So once you pick the angle that you know on the unit circle, we know 210 on the unit circle. Maybe. It's a little harder with degrees. You're so used to working with radians. We're then going to grab the formula. And the formula says take 1 minus the cosine of that angle. That angle that we're using, this is x, is 210 degrees. And then we're dividing that by 2. So 1 minus the cosine of x. Well, x is 210. And then we're dividing that by 2. Well, let's talk about 210 degrees. Is that a 30, a 45, or a 60 degree angle? So which family goes with 210? Kate? 30. It's a 30. Nice job, Kate. So this is a 30 degree angle. That's in the 30 degree angle family. So Kate, we have to evaluate the cosine of a 30 degree angle. Don't think about the 210 right now. What would the cosine of a 30 degree angle be?
Over 10, or root 3 over 2.
Perfect. So she said root 3 over 2. And then Kate is 210. Quadrant would that be? So is the cosine of 210 positive or negative? Awesome, nice job. So we're picking this value because that's the number on the unit circle. We're evaluating it, finding the value of cosine at 210 degrees. Come on, board. There we go. And that's the number then that gets plugged into the formula. So we have 210 degrees. The cosine of it is the square root of 3 over 2. It's in the third quadrant. Cosine is negative in the third quadrant. Now you need to do some algebra. So we did the trig part. Now it's just simplifying this algebraically. That plus or minus is going to stay there. So I'm going to keep the plus or minus. We're going to do that last. We're just going to see if we can evaluate this. So find a common denominator. Chelsea, if I have 1 minus the square root, or negative square root of 3 over 2, the 1 would become a 2. The minus negative becomes a big plus, and that fraction on the top becomes
2 plus the square root of 3 over 2.
And then all of that is still divided by 2. So Chelsea, if you have 2 plus the square root of 3 divided by 2, and then you're dividing that by 2 again, what does that really mean you're doing?
You technically would be multiplying.
You're so close. So if you're dividing everything by 2, you're technically multiplying by. Yeah. So this part here where it says divided by 2, the big value of the big fraction underneath. When you're dividing everything by 2, you're really multiplying by a half. So dividing by 2 means multiplying by a half. So we got the plus or minus. We have a square root. We have 2 plus the square root of 3, and now divided by 4. So this 2 and that 2 give us that value of 4. Now there's one last thing that we can do to simplify this. When everything is underneath a square root and you have a fraction, how can you simplify that? Virginia? Yeah. So really, when everything's underneath a square root, you can look at it as 2 separate square roots. The square root of the stuff on the top, the square root of the stuff on the bottom. That works the same way with squaring. You can square the top, you can square the bottom. You can do them individually. That's called the quotient property. So we now have plus or minus the square root of 2 plus the square root of 3. That top part can't change. But the bottom part can become a 2. Because isolating that square root of 4 underneath can become just a 2. Questions? So I think the half angle formula is the one that's kind of the most involved. The last thing that we have to do now is look at that plus or minus. That plus or minus in the front goes back to whatever you're finding. And really, we were trying to find the sine of 105 degrees. So you choose a plus because the sign is positive in the quadrant wherever it's located, or you're choosing the minus because the sign is negative in that quadrant that the angle is located. So if you look at 105 degrees, what quadrant would 105 degrees be located? Chelsea?
The second quadrant.
Right. So because our goal is to find the sine of 105 degrees, and this is in quadrant 2, Chelsea, is the sign positive in the second quadrant or negative in the second quadrant? Positive. So we're picking the plus, and I'm actually putting a plus here just to emphasize we're choosing the plus of the 2 of them. 2 plus the square root of 3 over 2. And again, the reason we're picking the plus and not the minus is because the sine of an angle in the second quadrant is positive. If this were the cosine of the angle in the second quadrant, then my answer would be the minus. So if we ended up finding cosine instead of sine, I'd have a minus in front here. Questions? Because it's tricky, because like you're using one angle in the formula, but then you still need to look at the answer for the outside plus or minus. Like what was our end result? Well, we were trying to find the sine of 105 degrees. So Brandon, do you have that one memorized now? Yeah. Questions? So there's one other problem underneath, and it's the solve the equation problem. So we use the formula in the first one to help us evaluate. This one now is just finding the solutions. And we have 2 minus sine squared. That's equal to 2 times cosine squared of x over 2. And just on the right side here, to get you to think about this in a different way, when we square a function, we usually put the square with trig in between the cosine and the angle, but that's the same thing as having the little square on the outside as well. They mean exactly the same thing. It just depends on where you want to locate that little squared part. So just kind of think of that as really being cosine of x over 2 and then that thing being squared. It means the same thing, I'm just moving the location of the squared term. So our goal is to solve, which means we want to find x, which in the end would be an angle solution. What can we replace? So look above in the box. Virginia, what can we replace?
The cosine x over 2 can be the square root of 1 plus cosine x over 2.
Good. So with the other 2 groups of formulas that we looked at, we took out the notation. This is the notation for a half angle, and replaced it with its formula. So we're taking out that notation, cosine x over 2. Once you replace it, that whole thing is still squared. Libby, what could you do to simplify this? We did the trig part, now we want to do some algebra. So on the right side, what could we do algebraically to simplify all of this stuff over here?
You could get rid of the square root.
Yeah, because
It's square.
it's squared. So the square and the square root cancel. The plus or minus also cancels as well, because whether you square a positive or a negative, it always remains positive. So the plus or minus is going to cancel. So now we just have 1 plus cosine divided by 2. Libby, what else can we do on the right side?
You can get rid of the 2 in the denominator because they're multiplying by 2, so they also cancel out.
Great. So a nice thing that all this stuff cancels. So the 2, we're multiplying, we're dividing. Now we have 1 plus cosine. Okay, so we did everything algebraically on the right side. Now let's talk about trig for the left side. It says 2 minus sine squared. And on the right side we have cosine. So thinking back to pretty much like the equations we did last week. This is what an equation would have looked like that you had last week. 2 minus sine squared equals 1 plus cosine x. What could you do with the left side? Michael?
You split the 2 into a 1 and 1, and make the 1 minus sine squared of x cosine squared.
Nice. So, again, it depends on how you see the problem. You might not have thought to do it this way, but Michael said the 2 really can be written as 1 plus 1. Just like 2x is x plus x, 2 is 1 plus 1. We still have the negative sign squared. So this is just kind of looking at the problem, rewriting it slightly differently. And then he said 1 minus sine squared is the identity, and it's equal to cosine squared. So just by taking that number 2 and splitting it up, then you can take the identity and replace one of those ones with the minus sine squared. Michael, what would your goal be then after you did that?
Then you want to set it to 0.
Perfect. So set it to 0. Subtract the 1 on the other side. Well, they cancel because you're taking it positive 1 minus 1. And then we have cosine squared minus cosine. Eris, if you have cosine squared minus cosine, what would you do?
I'm just taking out a cosine.
Yeah. Take out a cosine. We're left with cosine minus 1. It's factored. Take each piece, solve. We've done all the algebra we can do. Now it's back to trig. Setting them equal to 0. So these problems go from trig to algebra, trig, algebra. They're going to end with trig because the end result is trying to find the angle. So what angle has a cosine of 0? Brandon?
Pi over 0 and 3 pi over 2.
Yeah, pi over 2, because this ordered pair is 0, 1, and 3 pi over 2. That ordered pair is 0, negative 1. So pi over 2 and 3 pi over 2. Brandon, on the other side, what angle has a cosine of 1?
Pi is 0. Oh wait, just 0.
Just 0. So the angle 0 has an ordered pair of 1 for cosine and 0 for sine. So that's also going to be one of the solutions. Questions? So I think they're a little more, like the half angle ones are just a little different with that plus or minus. You got a square root in the problem, and then they end up having square roots underneath the square root. So I'd like you to flip to page 33, just so you can see what that looks like. So the review worksheet, 1 of 3. This one is pretty much just using the identities and the formulas. There is no solving on this page. The other page, page 35 and 36, that's the one where you have 3 that you're solving. So this one is just using the identities. I have that like identity sheet out so that you can kind of see it because this is a little bit of matching. So if you look at number 1, the goal for 1 through 6, I think, wants you to write the function as a single angle. So right now, it might be an expanded form. We want to condense it by matching it with one of the formulas that it looks similar to. What does number 1 look similar to? So 2 sine 8x cosine 8x. What does that look close to? So look on those formulas. Michael?
Sine of 2x.
Yeah, this looks very similar to the sine of 2x. The sine of 2x says sine x cosine x equals sine 2x. So right here is the formula. That's what it equals. It's the sine of a double angle. So very similar to number 97, whatever your angle is, and in this case that's 8x, that's replacing the angle in the formula. So you're really taking sine of 2 times the angle of 8x, and you're doubling that, hence the double angle formula, and you get the sine of 16x. That is written as a single angle. So decide which formula it looks like, and then once you choose that formula, you're taking whatever angle you're given and plugging it in. So if you look at the one next to it in number 2, we have the square root of 1 minus cosine of 4x divided by 2. Which one does this look like? Look at the formulas. Which one does that look like? Eris?
Sine of x over 2.
So she said this looks like the sine of x over 2. Except the x, the angle is 4x. So you're taking that 4x, plugging it in for your angle, and then cutting that in half. Because you're taking half of the angle. So this becomes the sine of 2x. Questions with that? So you're kind of matching the formula, plugging in the angle, and then just simplifying it. The next group of problems is similar to the one that Virginia did. You only need to draw the diagram once. So draw a diagram for sine of x, draw a diagram for cosine x. All of the next 6 problems then use the formulas. You're going to expand them and plug in the values from the triform. And then the last 2 problems I think are like the proving the verifying. Questions? So tomorrow, come with questions that you have, whether it's on these worksheets, the worksheet with the equations, any of the other homework that we didn't get to that you still have questions on. This is the partner test due on Tuesday. And then I have the 2 word problems. One deals with temperature for Fairbanks, Alaska. The other one is a baseball problem with Willie Mays. Feel free to take both of them. Whichever one you think you feel more confident about, you're handing that in on Tuesday as well. Questions?